We present Kai, an Eulerian water simulation plugin for Maya 2012, a project by Zakiuddin Muhammad and I, Karan Srivastav. The goal of this project was to develop a Maya water simulation plugin that is quick to set up and easy to use. Our target audience includes artists and technical directors. The simulation can be previewed and interactively tweaked within the limit in the Maya workspace. We automate the process of rendering water by specifying a custom mental ray water shader. At the very least, this provides a platform from which the artist can tweak the water's visual appearance. In keeping with our one-click interaction theme, we provide a similar mechanism for embedding arbitrary geometry into the simulation grid, allowing for rich water-terrain interaction. The water simulation approach we follow is outlined in the paper Real-Time Eulerian Water Simulation Using a Restricted Tall Cell Grid by Matthias Müller and Natapong Chentenes of NVIDIA Research. The water is simulated in an Eulerian grid. A unique characteristic of liquid simulations is the need to track the surface, and for this, we utilize the level set method as presented in the paper Practical Animation of Liquids by Fedke and Nick Foster. We store the level set at cell centers. We also utilize the ghost fluid method, which specifies conditions to ensure that the pressure is zero exactly at the free surface of the liquid. This enables a more accurate representation of the free surface. We also use the solid fraction method proposed by Batty and others in 2007 to correctly handle cells partially occupied by solids. To render the isosurface, we use the marching cubes method, in which a cell is checked to see if it contains a surface. The location of the surface is given by one of 15 cases. For solid objects, we generate sign distance values and store them at each grid point for accuracy. We began with a pure C++ implementation rendered using OpenGL primarily because it let us visualize values that greatly helped in debugging the simulation. Once we had a robust simulation, we moved to integrate it with Maya using its MFN fluid node in conjunction with MPX fluid emitter. Finally, we wrote meld scripts for the GUI elements of the tool and to send required information to the C++ simulation engine. We implemented the physics computation for simulation of water, which includes, among other things, level set computation, velocity extrapolation, incompressibility enforcement, and terrain integration. To aid us, we utilized the smoke simulation framework from CIS 563's base code, SDFGen, and the solid fraction method written by Christopher Batty. The following video demonstrates our plugin. First, we create a simulation container by clicking on the Create Container item in the Kai menu. This creates a 10-cube grid by default and can be readily simulated on. To edit the simulation attributes, we select the container and pick the Edit Attributes option. This opens a dialog box that allows us to modify simulation attributes interactively. In this example, we increase the grid dimensions to 20 cube while keeping the grid size the same, thereby changing the cell size. In this case, interactivity is demonstrated through modifying the velocities at the source along each axis. To embed terrain, we select a polygonal mesh and the container and select the Embed Terrain item in the Kai menu. Now, as we run the simulation, we see that the fluid interacts with the object. The default rendering, while sufficient for a preview, falls short for a final render. For a final rendering, select the grid and click on the Create Mesh option. This creates a polygonal mesh and attaches a mental ray water shader to it. Demonstrates the output from our plugin. The simulation runs in a 100-cube grid. Water is emitted from a spherical source for a user-defined number of frames with a force specified by the user and interacts with arbitrary terrain. The demo uses the water shader automatically assigned by the plugin and is rendered in Mental Ray.